Hello, Algebra 2. So today we're looking at recursion and iteration. So far when we've been talking about patterns, we've been talking about series, our numbers have either been going up or down by the same thing. We've been adding, subtracting, if it's arithmetic, multiplying or dividing, if it's geometric, and we haven't really looked at anything that's not one of those two things in detail. Today we're looking at what happens if it isn't just one of those things, and a way to describe a pattern if it's not just adding, subtracting, multiplying, or dividing, what if we're doing some combination of those things. So the ones we're going to be looking at today, we're going to have something that looks like this, which looks like a bunch of nonsense until we remember that if we have a with a little 1 down here, that just means that's your first term. So anytime you have an a with a little 1, a sub 1 there, that's your first term. So that's our first term, and then this other stuff is just telling us how to get to our next term. So we're taking our next term, and we're going to get it by taking 2 times the term we've got. So this is a term we have. And we're going to take it times 2 and then add 3. Not sure if you can read that. So a sub 1 is your first term. This is our next term. This is the thing we're looking for, and we're getting it by taking the term we have and plugging it in here. Okay, so if we want to say find the first 5 terms, we've already got our first one. First one's a freebie. So your first one is 5. And then to get the next one, we're going to take that 5 and we're going to plug it in. So we're going to take 2 times 5, that gives you 10, and then add 3, that gives you 13. And then we're going to do that again, but with the 13 now. So we're going to take 2 times 13, that gives you 26. 26 plus 3 gives you 29. And then we're going to do the same thing with the 29. So 2 times 29 gives you 58. 58 plus 3 gives you 61. And then we said first 5, so your next one is going to be 2 times 61 is 122, plus 3 gives you 125. So there we have our first 5 terms. Yay. Same sort of thing over here. So your first one's your freebie, that's our 8. Then we're going to take 4 times 8 is 32, minus 1 is 31. And then we're going to take 4 times 31, which is 124, minus 1 is 123. And this is where Miss P is going to grab her calculator. So now we're taking 4 times 123 minus 1. 4 times 123 is 492, minus 1 is 491. And then we're going to take 491. Times 4 minus 1. 491 times 4 is 1,964. Minus 1 gives us 1,963. Cool. So we got our first 5 terms. So if we're going this way, going from a function here to numbers here, that's kind of the easy part. You're just plugging things in, just plug and chug. A little bit tedious, but nothing too terrible going on there. We're generally multiplying, adding, subtracting. Nothing awful going on there. Where it gets a little bit trickier is where we're going backwards. Because we're going to have some numbers, and we're going to have to figure out, okay, well, what are we doing to get to the next number? So what am I doing to get from 8 to 23, 23 to 68, 68 to 203, and so on? Now, so far I've been dealing with either it's adding, subtracting, multiplying, or dividing, so you can either subtract or divide these two numbers to get what's going on. That's not going to work here, because we're not just adding or subtracting or multiplying or dividing. We're doing some combination of those things. So what we're going to look for is we're going to look for, okay, if I want to get from 8 and I want to get close to 23, we're going to look for something we could either multiply or divide by to get from 8 close to 23. So we're going to 8 times 2 is 16, 8 times 3 is 24. Ooh, that's close. So if we take it times 3, to get to 24, and then we subtract 1. And then we just want to see, is that going to work with the other ones? Because we don't just want something that's going to work with your first two terms, we want something that's going to work all the way through. Because otherwise we could just say, well, I'm adding 15. Well, yeah, that would work with these two, but not once you get past the first two numbers there. So if we take 23 times 3, that gets you 69, subtract 1, and you've got 68. Looks good so far. If we take 68 times 3, we've got 68 times 3 gives you 204, minus 1 gives you 203. Okay, we found our pattern. So now we just want to write a recursive formula for that. And again, we want two parts. So we have the first part is your first term, so a sub 1 is 8. So that one, again, is kind of a freebie there. We just want to make sure that we say it, because otherwise, if we just say we're taking it times 3 and subtracting 1, we don't know where we're starting. So we want to say where we're starting, and then we want to say what we're doing to get to our next term. And we have our term that we have, and we said we're taking it times 3 and then subtracting 1. Which you could either write like that, or if you wrote it like 3 times a sub n and then minus 1 there, that would also be fine. Or if you left out the dot and didn't say you're multiplying there, that's also fine, because if we have a number next to a letter like that, that means we're multiplying. So either this or this would be fine. So we definitely want this part, and then either this or this. So we want a sub 1 and then either this way of getting it or this way of getting it. Either one's fine. If you're multiplying, order doesn't matter. Just want to make sure we've got both parts. Okay, let's try the one. So this time, if we want to get from 108 to 56 to 30 to 17, we want to figure out, okay, what are we doing? What can we do to 108 to get close to 56? Or what can we do to get 56 to get close to 30? What can we do to 30 to get close to 17? And in general, it's going to be easier to figure out what's going on if you look at your smaller numbers. So here it was easier to go from 8 to 23 than was to figure out, okay, how we're getting from 68 to 203. So even though it's later in the pattern, I'm going to look at that 30 and that 17. And we want to figure out what can we do to get from 30 close to 17. So we're not going to be able to get from 30 exactly to 17 unless we're subtracting 13. But if we're looking at what's going on earlier in the pattern, we're not subtracting 13 there. Okay, but if we take 30 and we divide by 2, that would get us to 15. That's close. So if we say, well, we're dividing by 2 and then we're adding 2. Now I just want to see, is that going to work for the rest of the pattern? So if I take 56 divided by 2, that gets me 54. 54 plus... If I take 56 divided by 2, that gives me 28. 28 plus 2 gives you 30. Okay, that checks out. 108 divided by 2 gives me 54. 54 plus 2 gives you 56. Boom, there we go. Now, that's not the only thing that would have worked. You could have also said, well, if I want to get from a 30 to 17, I could add 1, 2, 3, 4 to get me up to 34, and then I could divide by 2 to get 17. So you could also say, we're adding 4 and then we're dividing by 2. That would also work. So usually there's going to be more than one way to get to the right answer. So if you're double checking your answers in the back of the book and you don't have exactly the same thing, but you know that your pattern works, that's okay. There's more than one thing that would be okay. So again, we're going to start off with our first term is 108. And then to get to our next term, we're either taking our next term, n plus 1, we're either taking our previous term and we're dividing by 2, which I'm going to write as a fraction, and then we're adding 2, or we said the other thing that could work is if you said we're adding 4 and then we're dividing by 2. So either of those things would be okay, because those are both ways to get to the right answer. Now, just a heads up that if you're writing it like this instead, then want to make sure we put some parentheses around here so we know we're taking that plus 4 first and then dividing by 2. Because otherwise, if we look at order of operations, it looks like we're doing division first. We're taking 4 divided by 2 and then adding it to our previous term. That's not what we want. We want to say we're taking this whole thing plus 4 and then divided by 2. So if we want to say we're doing the plus 4 first, that needs to go in some parentheses. Now, if you had it in a fraction, it can just stay like that. You don't need the parentheses, because if we have a fraction, there are automatically parentheses around there even if we don't put them there. And that's why you want to watch out for, if you're doing it this way, that too doesn't go in your fraction. So if you're adding first, it goes in your fraction. If you're adding second, it's outside of your fraction. So watch out for those. Alright. Last thing we're doing with these is we said at the start that this was a recursion and iteration. That was the recursion part. Now we're going to look at iteration. But nicely, it's pretty much just another way of writing the same sort of thing. So if we have a function like this, and this is our first, or this is our initial value, and we want to find, say, the first 3 iterations, we're really doing the same thing we've been doing. We're going to take that 10, and we're going to plug it in for x. So if I want, say, the first 3 iterations, actually I think they call them iterates. Yeah, okay, iterates. Same thing. So if I want the first 3 iterates, we're going to take that 10 and we're going to plug it in. So negative 2 times 10 gives you negative 20, plus 5 gives you negative 15. Now, watch out for this time, we don't want to include the thing that we're starting with, because that's a 0 there, not a 1. So if there's a 1 there, we're getting our first term. If it's not, we don't want to include it, because this is our first term, not this. Because this has a 0 here, so that's kind of our 0th term. It's a term that before the sequence actually starts. And then we're doing the same thing, so we're plugging in negative 15. Negative 15 times negative 2 is a positive 30, plus 5 gives you positive 35. 35 times a negative 2 gives you negative 70. Negative 70 plus 5 gives you a negative 65. So we're really doing the same thing we were doing with the other ones, we just don't want to include this number. It's just here to help us get to the first term. It's not actually our first term. So that's really the only difference between this and the other thing we were doing. Alright, same sort of thing over here. So if I want my first 3 iterates, again, we don't want to include that 4. We're just taking 3 times 4 squared plus 7. Now, watch out for my plug it all into your calculator, people. Either plug it all in at once, or you want to make sure you're squaring that 4 first and then taking it times 3. So don't take 3 times 4 and go, oh, that's 12, and square that. Don't do that. PEMDAS. Exponents come before multiplication. So we're taking 3 times 4 squared is 16, plus 7. 3 times 16 is something. 3 times 16 is 48. 48 plus 7 gives you 55. So that's actually the first term. Now we're going to do the same thing, but replacing that 4 with a 55. And you may notice these get big pretty quick, because 55 squared is 3,025. Times 3 plus 7 gives you 9,082. So good thing we only wanted the first 3, because this is going to get pretty big, because now we're taking 3 times 9,082 squared. So we're taking 3 times 9,082. Oops. 9,082 gives you a really big number. Don't mind that sound, it's just my cat tearing up the bed. 1024 plus 7. So taking that times 3 and then adding 7, which gives you 247,448,179. Now, I left out the commas in that because it's kind of confusing to have commas here and then also commas here. So just a heads up that if you're double checking your answer in the back of the book and you see something with commas here, this is your first term, this is your second term, this is your third term, the whole thing, even though there are commas here and commas here. So I'm just going to throw in some semicolons here to separate our terms so that we don't get confused. All right. And that's pretty much what's going on with recursion and iteration. Go ahead and check out the assignments in the description below, and I'll see you in the next video.